So welcome everybody to this latest video on 162 Maths, and in this video we're going over the AS Maths algebra topic of disguised quadratics. A disguised quadratic is where there is a function of x instead of x, which then forms a more traditional quadratic. So for example, if we had 2x plus 1 all squared plus 5 lots of 2x plus 1 plus 6 equals 0, then what most students would do is they would see this and they would probably expand this out, in which we would get 4x squared plus 4x plus 1. They would then go on and expand this, which would give us 10x plus 5, and we've got our plus 6. And then collecting all the like terms together, we end up with 4x squared plus 14x plus 12, which we can then divide by 2, giving us 2x squared plus 7x plus 6. And then we can then go on and solve this particular quadratic, which would give us an answer of x equals minus 3 over 2, or an answer of minus 2. Now, another way of particularly looking at this particular question is if I let y equals 2x plus 1, and I've just picked y just because it's a letter that doesn't kind of look like a number, then what I would end up with is I'd end up with y squared plus 5y plus 6 equals 0, and this then becomes a new quadratic equation with respect to y. Then from this I can then go on and solve this, in which I end up with y plus 3 y plus 2 equals 0, and then I can solve this for y, which is minus 3 or minus 2. Now if I then substitute back, knowing that this is the substitution that I have then used, so if y equals minus 3 and y equals minus 2, then 2x plus 1 will also equal minus 3, and 2x plus 1 will equal minus 2. And then if I then solve this for x, I get 2x is equal to minus 4, and so x equals minus 2, and here if I end up with 2x equals minus 3 and x equals minus 3 over 2. And again, what you can see is I end up with the same particular answers. Now you might be thinking to yourself, well, this is a much longer way of doing it, but this is just an example just to show that this method works both for when you use a substitution and when you don't. Now when you end up with more complicated questions, which is what we're going to lead on to, then this is the technique that you want to be using. So now let's have a look at this worked example. So the question is asking us to solve x to the power 4 minus 13x squared plus 36 equals 0. Now this isn't a quadratic equation, it's a quartic equation, but what we can do is use this method of substitution to turn it into a quadratic equation. So typically, if you're not sure about what the substitution is going to be, if you find the lowest degree of x, then so use the lowest degree. Now what do I mean by degree of x? I mean the smallest power of x as your substitution. Then substitution, there we go. And so here if we let y equals x squared, then what this then becomes is y squared minus 13y plus 36 equals 0. Now the reason why it's y squared is because x to the power of 4 is the same as x squared squared, and what's in the bracket is equal to y, so therefore it's y squared. So let's just stick that in a bubble. So then return back to our quadratic. We now solve this quadratic, and does it factorize? Yes it does. So we've got y minus 4 y minus 9 equals 0, and then we solve it for y, in which y equals 4 or 9, and then what we then do is substitute our x back in. So if y equals x squared, then x squared is going to equal 4, or x squared is going to equal 9. Now solving this, we get x values of plus minus root 4 or plus minus 9, root 9, giving us an x value of plus or minus 2 or plus or minus 3. Now moving on to our second example, which if you wanted to have a go before we go through it, feel free to pause the video at any time, have a go at the question and then see if you're correct. So for this one here, with our smallest degree of t is t squared. So if we let y equal t squared as our substitution, then what we end up with is y squared minus 7y plus 10 equals 0. Then from this we can then solve it. Now you don't have to solve at A level, you don't have to solve it by trying to factorize it. You can go straight into using your A level calculator, whether it be scientific or calculator, it'll do the actual solving for you. So here we end up with y minus 5y plus 2, minus 2 rather. So y is going to equal 5 or positive 2. So therefore t squared is going to equal 5 or 2. So then if t squared equals 5, then t is going to equal plus or minus root 5. And if t squared equals 2, then t is going to equal plus or minus root 2. And there are our solutions for t. Now moving on to our third example, looks very, very similar to our previous one, but this one is asking us to give our answers to 2 decimal places. Now just like at GCSE when you're asked to solve a quadratic and it mentions anything to do with rounding, then basically this is going to imply that we use the formula or our calculator to solve. So return to this, we find that our lowest degree of x is 2. So if we let y equals x squared, then we end up with 6y squared plus 5y minus 10 equals 0. Then from this, what I then want to do is make sure it's equal to 0, and then if I reach for my calculator, I can then go on and solve this quadratic equation, in which I get an answer of I'm going to get y equals minus 0 plus 0.9399 to 4 decimal places, or I'm going to get an answer of minus 1.7732. Now when they mention anything to do rounding, that's what you want to round your final answer to. So if you end up in your working out ending up with getting some decimal numbers, then always go that little bit extras, just so that you're not losing any silly marks with regards to accuracy. Now when it comes to finding our y values, we can then find out what our x squared values are going to be. So x squared is going to equal 0.9399, and this one is then x going to equal plus or minus root 0.9399. Now if you've got it still on your calculator, you use the exact values, but with this I end up with an answer of plus or minus 0.97. So that's one of the solutions. So the next thing I then move on to is the second solution. So here I've got x squared equals minus 1.7732. Now for this particular case, if I then go on to square root both sides, then what then happens is I'm going to be, regardless of my plus minus, I'm going to be square rooting a negative number, which cannot happen. So for this, I'm going to end up with no solutions. Now, if you spotted that straight away, it is really important that you always state that if you have a calculation where there are going to be no solutions, always make sure you write down that there are no solutions. Failure to do so will mean that you lose marks in this particular question. So moving on to question 4, it says solve 6x to the power of 2/5 minus 9x to the power of 1/5 equals 7, giving our answer to 2 decimal places. Now the fact that it says to 2 decimal places again means that we do not attempt to factorize. So don't factorize when you end up with the quadratic. It's going to be a case of our answer is going to be decimal numbers. Now the first thing to note with our equation is that it's not equal to 0. So first things first, let's make that equal to 0. In which the second thing I noticed now is that we've got fractional powers. Now although it looks more complicated, nothing to fear, we're still using that same method. So here I look at the lowest degree of x, which is 1/5. So if I let y equal x to 1/5, then what I'm going to end up with is I'm going to end up with 6y squared minus 9y minus 7 equals 0. Remember that x to the 2/5 is x to the 1/5 squared, and if what's in the bracket is equal to y, then that's going to give me y squared. So then solving this equation for y, what do we end up with? Well, we can go straight for our calculator to work that out. So I've got my coefficients of 6 for A, minus 9 for B, and minus 7 for C, and that gives me one solution of 2.06497 blah blah blah, or I get a solution of minus 0.56497 blah blah blah. Now again, that's the solving ifs for y, but now I need to substitute my x back in. So x to the 1/5 is going to equal 2.06497, or x to the 5th is going to equal minus 0.56497, and 1/5 is the same as a 5th root 97. So to find out what x is, all I've got to do is just raise 2.06497 to the power of 5, and the same thing with this is x is going to equal minus 0.56497 to the power of 5, and giving my answer to both of those, so 2.06497 to the power of 5 gives me an answer of 37.55, or if I then enter minus 0.56497 to the power of 5 gives me an answer of minus 0.06, and each of those answers are to 2 decimal places as requested in the question. Now, something you might find useful is looking at the solution notes. So one thing to notice that if your substitution involves a integer power, so for example, if I have let y equals x squared, or y equals, let's go for x to the power of 4, let's say, then you can see here that my power is an integer number. Now if the power is even when you've got an integer, so either x squared or x to the power 4, then the values of this can only be positive. So you can only have x squared equals to a positive number. If it's negative, there's going to be no solution. So if x squared, so there are solutions for this, and if x squared equals a negative number, then there will be no solutions. So it's worth mentioning for that. Whereas if the power is an odd number, then so for example x cubed, then you can have both plus and minus values will equal solutions. So just something to bear in mind. Now likewise, if you have fractional powers, if the denominator in the fraction is even, then the value cannot be negative, so that will produce no real solutions. But however, if the denominator is odd, then the value can be negative. So in other words, if I had x to the power of a third equals a negative number, then that would be absolutely fine. If I had x to the half and that equaled a negative number, so that wouldn't be fine. This one would produce no real solutions. So just something to bear in mind when you're working with, but if you just understand the work that you're doing, then you'll be absolutely fine. So now let's have a look at our 5th example. So this time, rather than having powers, we've got it in root form. So this question is asking us to solve negative 8 root x plus 9 equals 9x, giving your answer correct to 2 decimal places. So first things first, what we need to do is make this equal to 0. Now, one thing that you should notice is that another way of writing root 9 is to write it as using powers, which would be x to the power of a half. So taking this to this side, we end up with 9x plus 8x to the power of a half minus 9 equals 0. Now from this, what we can then do is let y equals x to the half, and substituting that in, we get 9y squared plus 8y minus 9 equals 0. Now the fact that it says give our answers correct to 2 decimal places will imply that this does not factorize. So if I substitute that all into my calculator, I get a y value of 0.6498, and I get a second value of minus 1.5387. Now the fact that we know that y equals x squared, x to the power of a half, then that means that x to the power of a half equals 0.6498, which implies that root x equals 0.6498, and then we can just square our value, in which what I'm going to end up with is 0.6498 squared gives me a value of 0.42 to 2 decimal places, and if x to the half equals minus 1.5387, that means root x is going to equal minus 5387. Now the root of a positive integer cannot equal a negative number, so although you may be tempted to square both sides, the fact that this is a positive root means that we can't end up with a negative answer, so this is going to produce no solutions. And again, really important that you state that if there are no solutions, you state it. So the only answers that we have is an answer of 0.42. So now let's have a look at a very similar question. It says solve root x equals 6 minus x, giving your answer correct to 2 decimal places. So for this, we've got x to the half equals 6 minus x. Then x is our highest power of our highest degree of x. We want to keep that positive, so let's take all of this over to the left hand side. So what that then produces is x plus x to the power of a half minus 6 equals 0. So again, if we let y equals the lowest degree of x, which is a half, then I end up with y squared plus y minus 6 equals 0. So now if I type that into my calculator to solve this quadratic equation, I get an answer of 2 or minus 3, in which then x to the half equals 2 or x to the half equals 3. X to the half is root x, so root x equals 2. So for this one, our root can equal a positive number, so x is going to equal 4. And for this one here, root x, so positive root, that should be a minus, can't equal a negative number, so for this we have no solutions. So now let's have a look at an exam style question. So for question part A, it says given that y equals 3 to the x, express 3 to the 2x plus 2 in terms of y. So for this, let's have a look at this. So here what we'd recognize is that 3 to the power of 2x plus 2 can be written as, now when do we add the powers? Well, we add the powers when we are multiplying, so that's going to equal 3 to the 2x multiplied by 3 squared. Now I can rewrite this as 3 to the x squared, and 3 squared gives me 9. Now 3 to the x we've been told is equal to y, so that's then going to equal y squared multiplied by 9, which then simplifies to be 9y squared. Now if I then move on to b, so b then says 3 to the power of 2x, and let me just write that a little bit properly. So we've got 3 to the 2x plus 2 minus 10 times 3 to the x plus 1 equals 0. Now it says hence or otherwise, but this is what you do with these particular questions, is that this then becomes 9y squared minus 10. Now 3 to the x is also y plus 1 equals 0. And now we've got our quadratic equation, which I can now go on and solve as per. So for this, on the calculator or using the quadratic formula, I get an answer of that y equals 1 or 1/9. Now from this, what I can then do is then substitute my x back in. So that means that 3 to the x is going to equal 1, or 3 to the x is going to equal 1/9. Now what's the power of 3? Sorry, 3 to the power of what gives you 1? Well, x must equal 0. And then rearranging, writing 1/9 as the reciprocal of 3 squared, that will give me an x value of -2. So our two solutions that we have for this particular question are 0 and -2. Now these three questions are very similar to the previous worked examples, so if you wanted to have a go at these questions before we go through the work solutions, then feel free to pause the video, have a attempt at these questions, and then unpause and see if you got the questions correct. So for question 1, what we've got is we can rewrite this as 2 to the power of x squared minus 17 2 to the x plus 16 equals 0. Now from there, what I can then do, let's just change this to make it a little bit easier to see, is I can rewrite this as y squared minus 17y plus 16 equals 0. Now from this, what I can then do is use my calculator to tell me what the answer to that is, in which I end up with a y value of 16 or 1. So from this, what I then know is that 2 to the x equals 16 or 2 to the x equals 1. And then using knowledge of powers, we've got 2 to the power of what gives you 16? Well, x is going to equal 4, or 2 to the power of what gives you 0? That's going to be x equals, for this one, is going to be 0. Then for number 2, if we let y equal, for question 1, again, it's really important that you do state what your substitution is. So here we let y equal 2 to the x. And so for this, if we let y equals, and this is going to be 3 to the x, then what we end up with is we end up with y squared minus 12y plus 27 equals 0. Going on to solve that, we end up with a value, y value of 9 or 3. So therefore 3 to the power of x equals 9, or 3 to the power of x equals 3, in which we get x values of 2 or 1 for that. Then moving on to our third example. Now here, this one is just a little bit tricky because we've got a 4. Now with 4 to the x, that is the same as 2 squared to the power of x, which is the same as 2 to the x squared. So if I replace 4x with 2 to the x squared, what I end up with is 2 to the x squared minus 10 2 to the x plus 16 equals 0. And if I let y equals 2 to the x, then what I end up with is y squared minus 10y plus 16 equals 0, giving me y values of, let's just plug that into my calculator now, of 8 or 2. So therefore, using the substitution, 2 to the x equals 8 or 2 to the x equals 2, in which I'm going to get an x value of 3, or it's going to be 1. And there is my answer for question 3. So now let's have a look at another exam style question. Again, this question in the exam paper was worth 5 marks. We can also see where the 5 marks are allocated for this particular question. So again, we've got fractional power, so always start by stating what substitution you are using. So for this, I'm going to let x equals x to the power of a third. So using that, what we end up with is a quadratic equation of y squared minus 17y plus 16 equals 0. So going on to solve this, then what I end up with is an answer of 16. So this actually factorized to y minus 16, y minus 1 equals 0. So y is going to equal 16 or positive 1. Then I substitute my x back in. So x to the third equals 16 or x to the third equals 1. Remembering what x to the third looks like, it looks like the cube root of 16 or the cube root of 1. This will give me an answer of cube root of 16. Well, cubing it would be 16 cubed, which will give me an answer of 4096, or 1 cubed, which is 1. So there are my two answers. Now typically, where would the 5 marks be awarded? Well, you'd get 1 mark for using a correct substitution, 1 mark for substituting into the quadratic, 1 mark for finding the values in respect to solving the equation with respect to y, then substituting it back in, and then 1 mark for your possible answers. And again, if there are no solutions, always make sure that you are writing it.